We are going to examine the eclipse times of a sun-synchronous orbit, which has a height of 400 kilometers above the Earth, and it has a LTAN, local time of ascending node at 6 a.m. and the descending node is at 6 p.m. So this means that the orbit is crossing the equatorial plane always at 6 a.m. and 6 p.m. So at first sight it might be that it's always on sunshine, our satellite, but this might be not true. In summertime, for example, 21st of June, we're starting our observation period, and we can see here there is some shadow. So the sun-synchronous orbit has this inclination of the sun-synchronous orbit to the equatorial plane. In our case, it's 97 degrees. And we can check if this shadow is affecting our satellite. So if we are searching for the sun, somewhere we have to, the sun we can see here, and if we check, so here summertime, if the orbit is still above the Earth and we can see the sun, so this means that in summertime our satellite will get always sunshine, and this, so if we are proceeding forward, if we go forward in time, we can see that the orbit is processing almost 1 degree per day. This means that it will stay in synchron always with the sun. Sometimes the moon appears here as well. So if we go until 20th of September, this is when we have even less danger of eclipse, because at 20th of September the equatorial plane and the ecliptic plane is the same. So here we have even more sunshine, even less danger that our orbit is hiding behind the Earth. You can see it's here, it's almost the sunshine, and the shadow, it's almost at where our satellite orbit is. The small difference is because we don't have exactly 90 degrees, we have 97 degrees. And if we proceed forward through winter, so in December 21st, we can see that somehow it's bigger, the difference between, this is the light area and here is our orbit. So if we are searching for the sun, then we can see that our orbit is hiding behind the Earth. So here we have an eclipse. And we can check with the SDK more details about this eclipse. If we have a graph report, then we can see that this eclipse is from about end of October till February. These triangles in SDK means penumbra. This penumbra we have it because although it's very far away the sun, and we can almost consider it's like a the source is a point, but it's not exactly point because it still has a so it's about 150 million kilometers the distance, but the sun diameter, it's pretty big. It's almost it's some 800 million, no, 0.8 million kilometers. So it's about 0.9% the sun's diameter compared to the distance from the Earth. So therefore we will have some penumbras. So it means that one part of the sun it's not illuminating, but the other part is illuminating. So these triangles mean here these penumbras. And so if we want to have the numbers, so we can see that in the end of October we have only a few hundred seconds the duration of the eclipse, but if we go to 21st of December, then it's about 1,400 seconds. So this is about 25 minutes. And yeah, so it can be calculated analytically, of course, with 3D geometry, but that can be the subject of another video. And it's one more interesting thing is that in the beginning and the end we have some penumbras from the moon. This we can see here in the graph as well. So the moon can do so here when we have this separate penumbra. It's the moon is causing some very small eclipse as well. So that would be. So the conclusion is that yes, we can calculate. So this was just an intuition to have about what should we calculate analytically. Thank you for the attention.